Hi everyone, this project is belong to Mr. Rith and Mr. Nuthapat. Today we gonna present parallel project. Almost all of the modern computers today have a CPU with multiple cores, providing extra computational power. In the new age of big data, parallel execution is essential to improve the performance to an acceptable level. With parallelization comes new challenges that needs to be considered. In this work, we will write OpenMP for the O-Net score system with two algorithms, parallel version and sequential version, and compare execution time of this two. The parallel version is faster, but if we use it with small data set, it will run slower than sequential version. If we use too many thread, it may run slower too. We use OpenMP with fork/join model. Fork/join model. All OpenMP programs start as a single process called master thread. The master thread will execute sequentially until it met with parallel region construct. Fork, the master thread then creates a team of parallel threads. The statements in the program that are enclosed by the parallel region construct are then executed in parallel among the various team threads. Join, when the team threads complete the statements in the parallel region construct, they synchronize and terminate, leaving only the master thread. Okay, let's see the code of parallel version. Include all essential header and define the number of threads. Initialize variables we will use. Random student exam ID and score into array of each subject. Record start time. For loop we use omp to let it run in parallel with t threads and private I. In for loop we find average score of each student and find max/min. We use sum to record the summation of each subject's score for calculate mean later. Find mean of each subject from values we got from for loop. Find SD of each subject. We use parallel to reduce time when calculated SD. Function POW and SQRT can be used after we include header math.h. We print max, min, mean and SD of each subject. After that, we record the time. Here because in the next line the program will wait for user input. We do not need this waiting time because it is not execution time. Student can type his/her exam ID here to find his/her score. After program receive the exam ID, it will record time. We use parallel for search algorithms. After that, we record the time at the end of the code. We execute time of the program and print it out. And this is sequential version. Sequential version has several things same as parallel version. As you can see, the parallel algorithm will run slower when dataset is small because the communication overhead. If dataset is not large enough, we better use sequential algorithms. If we use too much thread, it may run slower than sequential version. This depend on works of each thread. If we use more thread but each thread run only small job, it may run slower than less threads because overhead. Each thread should do reasonable size of job.